Assalamu alaikum guys. In this lecture we are going to study mesh current analysis. This technique is also used to reduce the number of equations we have to solve simultaneously while using KCL or KVL. Because we have seen in KCL and KVL we have to write equation for each node or for each element. First of all we will see what is the difference between mesh and a loop. We have seen in previous lecture what is a loop. Loop is if we traverse our circle from one node to the other node in a certain direction, it will form a loop. For example, we start from here and at the same node from where we started, this will form a loop. But what is a mesh? In mesh we do not leave any cross window, we do not leave any element. If we start from one node and at the same node, but in such a way that no element is left in the center. For example, in this loop this element is not included, so this is not a mesh. But if we go from this node to this node and then this node and come back to this node from this circle, then it will form a mesh. And while writing mesh current analysis equation, we will always use mesh. We will not write an equation in a loop. And there is another rule that if an element is coming in two meshes, the current of that kth element will be equal to IA minus IB. The current here IA will be here if, for example, the current direction through this element is in, जो करंट इस एलिमेंट का और जो करंट इस लूप का क्लॉकवाइज, ये दोनों एक डायरेक्शन में है, तो इस वजह से ए पहले आएगा और नेगेटिव में आई भी आएगा. अगर इस एलिमेंट के अंदर करंट की डायरेक्शन अपवर्ड होती और वो इसके कोहेरेंट होती तो इक्वेशन बनती आई बी माइनस आई ए. To understand this concept, we are going to solve an example. So this is an example in which we know the value of mesh current IA, IB and IC. We always take the direction of the mesh currents IA, IB and IC in the clockwise direction. This is just a tradition. We can also take in anti-clockwise direction, but in books and in literature it is always in the clockwise direction. Now we want to find the current I1, I2, I3 and I4, I5 and I6, the current of these elements. So the current in IA is the negative of I1 is the negative of IA. So I1 is equal to minus IA, so it will be minus 10 ampere. The current from I2, this element is shared in two mesh, so I2 will be equal to, the direction of I2 is same as the direction of IA, so IA minus IC. IA is 10 and IC is equal to minus 3, so it will be 13 ampere. I3 is also shared between two meshes, so I3 will be equal to, the direction of I3 is same as IA, so it will be IA minus IB. IA is 10 and IB is 5 ampere, so it will be 5 ampere. I4 is also shared, so I4 is equal to IB minus IC. IB is 5 minus IC is equal to minus 3 ampere, so it will be 8 ampere. I5 is simply IB because it is not shared and the direction is also same, so IB is equal to I5 is equal to IB, which is equal to 5 ampere. I6, the direction of I6 and IC is same, so the value of IC is equal to minus 3 ampere. In this way we can find the value of the element current knowing the value of the mesh currents. Now we will see the steps that are followed to write mesh current equation. So we will see the steps to write mesh current equation. First of all, we will assign a direction to the mesh current, and I have said earlier we will always take clockwise direction. So this is our mesh A and this is mesh B. The current is IA and current is IB. So we will write KVL equations for each mesh. So first we will start for this mesh, starting from here, minus V0 plus V1 plus V3 is equal to 0. The algebraic sum of the voltages in a loop is equal to 0. This is mesh A. For mesh B, starting from here, minus V3 plus V2 plus V4 is equal to 0. After writing the KVL equation for both meshes, we will write these voltages in the using Ohm's law. V is equal to IR in this form, IR form. And from there we will see the value of IA and IB. So V0 will be Vs1, this is source voltage. V1 is equal to IA multiplied by R1, IA R1. V3 will be equal to IA minus IB, because it is shared in two meshes, so the current will subtract IA minus IB multiplied by R3. Similarly, V2 is equal to IB multiplied by R2, and V4 is the source voltage, Vs2. Now we will put the values of these voltages in these equation, and we will convert these equation into IR form, and from there we will separate IA and IB, and we will find the values of IA and IB. So we will put first in this equation minus V0. V0 is equal to Vs1. So minus Vs1 plus V1 is equal to R1 IA plus V3 is equal to IA minus IB multiplied by R3, and it is equal to 0. Now we will separate IA terms. We can take this on the other side, R1 IA plus R3 IA minus R3 IB is equal to Vs. IA can be taken common, IA into R1 plus R3 minus R3 IB, and it is equal to Vs. This is our equation. Now we will put the values of these voltages in from here in this equation. Minus V3. V3 is equal to IA minus IB into R3 plus V2 is equal to IB R2 plus V4 is equal to Vs2, and it is equal to 0. So this is IA R3 plus IB R3 plus IB R2, and it is equal to minus Vs2. So this is IB R2 and this is IB R3. We can take IB common, and so IB into R2 plus R3 minus IA R3, it is equal to minus Vs2. This is our equation 2. In these two equations, we have separated the coefficient of the mesh current IA and IB. We can write them in the matrix form as we have written in node voltage analysis. Similarly, we will do the same step in mesh current analysis. So the coefficient of IA is R1 plus R3. Coefficient of IB is minus R3. In this equation, coefficient of IA is minus R3. And coefficient of IB is R2 plus R3. Here we will write IA, mesh current, these are unknowns, IB, and this equation is equal to minus Vs1, and this is equal to minus Vs2. This is our matrix A, this is X, this is B, X is unknown, X is equal to A inverse B. So from this equation we can find the values of mesh current IA and IB. In this example, we will see how to write mesh equations with inspection. Without writing KVL for the mesh, we can directly write the equation using this concept. First of all, for example, if we want to write the mesh equation for this loop for mesh A, what we will do? We will simply add the resistances in this loop. For example, in this loop, the resistance R1 plus R2. We will multiply it with the mesh current IA. Then we will subtract the resistance that is shared in any other loop. So R2 is shared in loop C, also in mesh C, so we will subtract it. So R2 multiplied by IC, it will be subtracted, and plus the voltage source. For example, this is Vs1, this is Vs2. So if we write equation, this will be positive Vs2 and it is equal to 0. So in this way we can write mesh equations by inspection. Similarly, we can write equation for this mesh B. So the sum of the resistances in this mesh R3 plus R4 multiply with the mesh current IB minus R3 is shared with this mesh, so it will be subtracted. So R3 multiplied by IC minus Vs2 is equal to 0. Now we will write equation for mesh C. This is for A, for B, equation for C. R2 plus R3 multiplied by IC. Now minus R3 multiplied by IB, it is shared with IB, and R2 multiplied by IA. These two will be subtracted. IA multiplied by R2, and the sum is equal to 0. So now we will put the values of R1 and R2. R1 plus R2. R1 is 2K and R2 is 4K, so it will be 60,000 or 6K multiplied by IA minus IB is 0 IB minus R2 is 4,000 IC is equal to minus Vs2. This is our equation 1. In the second equation, R3 plus R4. R3 is 4 and R4 is 2000, so it will also 6000 IB. IA is 0 in this equation, minus R3 is 4000 IC, and minus Vs2 is equal to Vs2 on the other side. Similarly, for mesh, this is A, this is B, and for C it will be R2 plus R3. It will be 8000 IC minus R3 is 4000 IB minus 4000 IA is equal to 0. These are the three equations. We can write them in the matrix form, and we can find the mesh current IA, IB and IC. There is a little mistake. This is not equal to 0 actually. R2 plus R3 multiplied by IC minus R3 IB minus R2 IA plus Vs1. This was missing. Plus Vs1 is equal to 0. So this will be equal to minus Vs1. We can write these coefficients in the matrix form. That will become a 3 cross 3 matrix, and the other X will be IA, IB and IC, which is equal to minus Vs2, Vs2 minus Vs1. So we can solve that this equation X is equal to A inverse B, and we can find values of IA, IB and IC. Now we will see what will happen if there is a current source in our circuit. As we discussed earlier in the node voltage equation, node voltage analysis, if there will be a voltage source in our circuit, it will simplify our node voltage analysis, because we will directly know the value of node voltage because of the voltage source. Similarly, if there is a current source in our circuit, it will simplify our circuit, and there can be three type of connections of the current source. First one is, if there is a current source in our circuit and there is a parallel resistance. What we can do, we can use source conversion and we can convert it into a voltage source with a series resistance, and the value of this voltage will be ISRS. This is RS. The second method is if there is a current source in our circuit and it is shared in just one mesh, for example IA. So we do not need to convert it. It will directly tell us the value of IA in this mesh. For example, if this current is IS, then the IA will be equal to IS. It will simplify our equation and we do not have to solve an equation for IA. The third case is when the source is neither in parallel with any resistance nor it is shared in one mesh. Rather, it is shared in two mesh. For example, it is a source and it is shared in two mesh. Now these are two meshes and the source is shared into different meshes A and B. In this case we will have to make a super mesh. We will ignore this. We will form a super mesh. We will write KVL equation for this whole loop. And the IA minus IB will be equal to IS. This IS. We will shortly solve an example to understand these three concepts. This is an example in which we have a current source in our circuit. We can solve it by two methods. It can be solved with the first method, in which there is a current source with a parallel resistance, and we will use source conversion to solve this. And similarly we can also, for example, if we make three meshes IA, IB and IC, then the IC will be known to us. We do not need to find IC because IC is equal to 2 milliampere, minus 2 milliampere. But so this is a current source and there is a parallel resistance also. We can convert it into a voltage source with a series resistance, and the value of this voltage will be equal to V is equal to IR. I is equal to 2 milliampere multiplied by 4 kilo ohm. It will become 8 volts. And the series parallel resistance will come in series with the voltage source. Now we have only two meshes. This is IA and this is IB. First we will write equation for IA start. As we have studied earlier, we can write the mesh equation using by inspection also. What we have to do, we will find the total resistance of this mesh. 3 plus 2 plus 1, 6K or 6000 ohms multiplied by IA. Now this 2 kilo ohm resistance is shared, so we will subtract it. 2 kilo ohm, 2000 multiplied by IB, and minus this is 5 volts. So minus 5 volt is equal to 0. This is our equation 1. Similarly, we can write equation for mesh B. Total resistance is 5 plus 4, 9 plus 2, 11. 11,000 multiplied by IB minus. This resistance is shared, so 2000 multiplied by IA plus, if we traverse it in this direction, this will be positive 8 volt and it is equal to 0. 6000 into IA minus 2000 IB is equal to 5 volt, and minus 2000 IA plus 11,000 IB is equal to minus 8 volt. So this will form a 2 cross 2 matrix. 6000 minus 2000 minus 2000 and 11,000, and IA IB it is equal to 5 volt minus 8 volt. So we can find IA by finding the inverse of this matrix multiplied by this. We can find the value of IA and IB. To understand the concept of supernode, we are going to solve this example. This is a current source and it is not shared in any other mesh. It is in one mesh, so the IA will be equal to IS1. This current source has simplified our example because we do not need to find IA. Similarly, this current source is shared in two meshes and we cannot write an equation like this for this source. So we will have to make a super mesh here. We will write an equation for this loop, for this outer loop. And we will use the formula IB minus IC will be equal to IS2. Now we will write the equation for this super mesh. This is super mesh. Sorry, this is super mesh. This is super mesh. So we will write equation for this super mesh starting from R1. R1 has I1 minus IB, or we can say IB minus I1. IB minus IA multiplied by R1 plus IC minus IA. IC minus IA multiplied by R2 plus IB multiplied by R3 plus IC multiplied by R4 is equal to 0. In this way we traverse this complete loop, that is our super mesh, and we write the KVL, we applied KVL and we write the voltages of each element in the algebraic sum form and it is equal to 0. So now we will simplify this equation. IB multiplied by R1 minus IA R1 plus IC R2 minus IA R2 plus IB R3 plus IC R4 is equal to 0. We will combine the terms containing I1. So I1 is equal to minus R1 minus R2, these two terms are multiplied by IA plus IB R1 and R3. So R1 plus R3 is equal to multiplied by IB. Similarly, IC R2, IC R4. R2 plus R4 multiplied by IC is equal to 0. We can take minus common from here, and when it will go on the other side it will become positive. So R1 plus R3 IB plus R2 plus R4 IC is equal to R1 plus R2 IA. And as we know, IA is equal to IS1, so we can replace it with IS1. And we want to find this voltage. For this voltage we need to find IC. So we will replace this IB from here. IB is equal to IS2 plus IC. So we will replace the value of IB in this equation. IB is equal to IS2 plus IC. So our unknown in this equation will be IC only. So R1 plus R3, IB will be replaced with IS2 plus IC plus R2 plus R4 multiplied by IC is equal to R1 plus R2 IS1. We will open this bracket. IC will be multiplied by R1 plus R3 multiplied by IC plus R1 plus this term R2 plus R4 multiplied by IC. And when we multiply IS2 with R1 plus R2, I am writing this on the other side, R1 plus R2 IS1 minus R1 plus R2 multiplied by IS1 minus R1 plus R3, R1 plus R3 multiplied by IS2. We can combine these two terms. R1 plus R2 plus R3 plus R4 multiplied by IC is equal to R1 plus R2 IS1 minus R1 plus R3 IS2. To find IC, we will divide this term on the other side. So IC will be equal to R1 plus R2 IS1 minus R1 plus R3 IS2 divided by R1 plus R2 plus R3 plus R4. So from here we can find the value of IC, and IC multiplied by R4, it will give the value of unknown, the voltage V0. So in this way you have now understand the concept of super mesh, and I have explained it with an example. So this is the end of our lecture. In this lecture we have completely learned what is mesh current analysis. We have solved example, we have solved mesh current analysis with current sources, we have understand the concept of super mesh. So this was the comprehensive lecture for the mesh current analysis. I hope you will have understand it. Thank you. See you in the next lecture.